Hey everyone, and welcome to our second session of the TBC Power Hour. Today we're going to take a look at identifying and resolving common field blunders in TBC. I'm Shane Lyons. I'm the technical product manager for Trimble Business Center on the geospatial side. I'll be monitoring the question box today. If you guys have any questions, go ahead and type them in there. I'll answer them best I can. If I'm unable to get you an answer today, I'll reach out to everybody individually afterwards, and we'll get whatever question you're looking at resolved. There's a lot to go through today, so if there's some more questions at the end, go ahead and type them in there, and then, like I said, we'll get back to everybody. So I'm joined today by Vector's Dustin Hoaglin. Dustin, you want to go ahead and introduce yourself and get started?
Absolutely. Thank you, Shane. All right. So I'm Dustin Hoaglin. A little bit about myself. I'm a licensed land surveyor from Colorado. I'm now the New Mexico Regional Manager for Vectors. I have 31 years experience. I've been doing this a long time. I now live in Albuquerque. I'm a Trimble certified trainer, TBC power user, TBC beta team member. I started using Trimble equipment back in the early 90s. I go all the way back with TSO, Trimble Survey Office, TSO. If those of you who are old enough and have gray in their beard like I do, they know what I'm talking about. I work for Vectors as a geospatial partner with Trimble, where we provide service and equipment to Colorado, New Mexico, and we also rent in the lower 48 states, across North America, and we're also a full service optical and repair facility. So reach out to us. One of the interesting things that separates Vectors from others is that we're really emphasized and focused on training and support for our customers that purchase through us. And that's how I kind of ended up here. For years, I was a customer and I really learned a lot. And now I've kind of come full circle and now I'm here teaching classes. So Shane reached out to me a couple months ago and said, hey, are you willing to do a power hour? I said, absolutely, if I can pick the topic. Well, why did I pick this topic? So after talking back and forth, this is a topic I get a lot of questions about. I get probably once a week, maybe more. I get a phone call from someone saying, hey, I've got this problem. Can you look at it with me? I can't figure out what happened. In surveying, we do our best and we're due diligent in trying to set everything up for success, right? We attempt, but we know that the realities of the field is something's going to happen. Something's going to get missed. The phone call is going to ring and mess you and distract you at the right time. A person's going to come up and do something, say something. Could be job related. It could just be somebody, some civilian walking up and driving you crazy that distracts you, but causes some error that you don't notice in the field, but gets carried over to the office. Also, as land surveyors, we're in this strange world where we have to be correct 100% of the time. We're not allowed to have any errors, right? The world expects us to always be correct, and we're not allowed that. We're not allowed that leeway. And then on top of that, our timelines are usually very, very short, and our customers expect us, and we've kind of created this environment where we're turning around our information very, very quickly. Even in my 31 years, the turnaround time has definitely expedited and raised, and things go in and out from the office to the field, from the office to the field, back to the office and to the client much faster than they did 30 years ago. So this is something that's constantly evolving, but that means that we have to go. So today's agenda in this power hour, and we have, like Shane said, we have a lot to cover. And so we're going to go pretty quick. Put your questions in there. We'll do our best to answer them as we go. If not, we'll reach out to you afterwards and make sure you get the answers you're looking for. Today's agenda is we're going to look at some field data. We're going to look at some best practices. We're going to evaluate the field data. How do you evaluate field data? How do you repair field data? And then Shane's going to go over some TBC resources. Okay, and if we have time, we'll do a question and answer. But we do have a lot to cover here. So field data. What I refer to as the path to success, has three main components, three major points. One is our SOP, our standard operating procedures. You know, if we have a good, solid SOP, hey, we can eliminate some things. The other one is points, control points versus control points, and file naming conventions. And the last and the most important that I can't emphasize enough are field notes. So let's talk about SOP. So the goal of having a well-established SOP is to eliminate the need to have to fix the data. If you have good standards in place and people follow those standards and it's this pattern, then you'll find yourself where you don't have to make those decisions. That would include methods for establishing control points. You know, when would you promote a measurement and the value that you measure with that measurement on a monument? When does it become a control point, right? And I don't think a lot of people think about that, but that's something you need to think about in your SOP. What kind of measurements, what kind of redundancy elevates a coordinate to being control quality? The other thing in your SOP is just data storage, and in a specific job file or in a database in TBC or even in CAD, what point numbers and ranges are you storing your points for different tasks that you're doing? Does control have a certain range? Do working points for temporary control have a certain range? Staking, topography, boundary, do they have a certain range? What does that look like? That helps you organize the data so that when you're working in a larger organization, you know, or even a small organization, which is a couple of field crews, they might be remote or they don't have cell phone. You can't get a hold of them, but you need to look at this data and figure out what's going on. Those number ranges can really help you sort out and understand what's happening. And then really, really important, time on point. If you're using RTK, time on point is what makes a big difference, right? I've seen so many cases where people are on there taking a 1 epic shot or a 2 epic shot. You know, what's the difference, you know, on a 5, you know, how much time does it really cost you to up those epics a few? Trust me, time is your friend when it comes to RTK, you know, giving that little more redundancy, allowing that, you know, covariance matrix to establish what's really going on there will save you a lot of time. Daily files, right? Daily files. I can't emphasize this enough. Daily job files. There's a lot of people I've seen over the years who go out and they'll start a construction project and they'll go out and they'll use the same file every day over and over and over again. And then 3 months later, working 5 days a week on the same construction job, 3 months later, something breaks in that file. Now they're like, oh, I don't have control. My job's corrupted. Well, if we would have made a control file up front on the first day or the second day on the site, and then use that control file to make daily files, we'd still be working, right? And the bigger these files get, the more chances you have for corrupting them. So don't do that, right? So naming convention of those job files, of those daily files, of those control files. And then lastly, your SOP, check shots, check shots, check shots. If you do not have check shots in your data when you're collecting it in the field, then I'm not just talking one at the beginning of the day. I'm talking one at the beginning of the day, one at the end of the day, and as many as that can be done during the day and still maintain your productivity. Those will allow you to repair your data. If you don't have that, you don't know if you fixed it or not. You don't know if you made it worse or made it better. You need those check shots, right? So it's worth it. Let's talk about naming, file naming workflows with your control files, right? The JXL file that you can export from the data collector, from Access, or from TBC after you've promoted your control point up with whatever method you've decided to evaluate your control. That JXL is important because you can't get in there in the collector and monkey with it. So you just basically take that control file, that JXL control file, and you convert it daily to your daily working file, right? Your working files, are your construction staking, your topos, your as-built, your boundaries after you've established control, you know, or a control file that's yet to be promoted would be a working file that is yet to be reviewed by the office and given the blessing of the LS in charge, or maybe, you know, or just comes back from the field and the LS was in the field and says, okay, now I've looked at it, I've thought about it, we're good, I'm promoting this to a JXL, it's locking down from this time on. Anytime I go out to this site, I'm using this JXL, that way everything's consistent. Very important. Now, in my career, I started pre-GPS, pre-RTK, and we used to take a lot of field notes. And this is an art that has kind of gone to the wayside with some companies, and I can't, if you don't have the notes, you can't fix the data, you can't fix the data. So what should be included in your field notes? In my opinion, and there could be other things I've missed, but this is a list I came up for the Power Hour. The date, who's on the crew today, weather conditions, name of the project or the project number, both, tasks, right? What's the task? What's the assignment for today? What is the JXL control file that was used to create this daily file? What is the name of this file so I know how to correlate it in the office? And what is the equipment being used? Like, what am I using? An SX10? Am I using an S series total station? Is an S5 and S7? What serial number? That kind of thing. It's very important. What if you find out, you know, a month later that there's been a problem with this total station? Do you know which jobs it was on? Do you, with that, can you track that data down? Where the equipment was set up, on what point numbers or names was the equipment set up on? And most importantly, the heights measured in the field, and every change that's made when you make a measurement in the field that's documented in these field notes, so that if something gets missed, then you can go back and find it in the data and change it correctly. If you don't write them down, you're not gonna be able to fix it. There's no way looking at the information in TBC that you're gonna be able to know to go back and change these rod heights or change this total station measurement method unless it's written down. This is what I did, right? Which includes, did you measure to the bottom notch on the total station, or did you measure to the true height, right? And then all the check shots. And I prefer, when I was managing field crews, I prefer they would list the check-in deltas. Not only did I check into point 205, this is the northern easting and elevation delta I saw at the time of my check-in. That way I know they're looking at it. I can look back at it, and then if I import it and I'm seeing something different, okay, something's gone wrong on the import. It's not that they had something wrong, it's that I have something wrong. Very, very important. Okay, and then anything out of the normal, you know, there's some funny stories of things that happen out of the normal, you know, all the time. But you know, that's you need to write down anything, and then all the information that, and anything I missed in this list that you could need to repair the data needs to be written down. If you don't have it, you can't fix it, right? I can't emphasize that enough. Okay, so let's look at evaluating field data. So the field data, it's really important. You need to develop your blunder sniffing skills, is what I call them. And this is a skill that can't be taught. It's a skill that you gain through experience. We're going to look at errors on import. We're going to look at computation settings, and we're going to look at the flags pane. Right. So on import, you get an import error. Boom. You drop in a job file from the field, you get this import error. Should I look at this report? Yes, you should look at this report. Is it going to be redundant sometimes? Yes, but at least you look at it and you say, okay, this point, you know, 5011 has no computed grid coordinates, right? So something happened in the field, whatever. So we can look at that. So let me open up TBC here. And we're going to open this up, and I'm going to open up a new TBC, and we're going to bring in a field file. So I've got a new file, US survey foot is my template, hit OK. And it's thinking slowly, there it goes. So I'll go into here. Here's my original field data. Here's my file. I'm going to take this and drag and drop this job file from the field into TBC. It's going to run through it, and it's going to import it, and it's going to pop up with that warning. Should you look at this warning? The answer is always yes. You should look at this warning. We're going to open this up, and it says the same thing. It says, hey, grid coordinates can be computed. Okay, we'll take a look at that, but we make a note of that point number. And I usually keep a pad of paper next to me, and I just jot down, okay, I need to go look at that. Is that something I care about? Is it not something I care about? That kind of thing. So now we have our data in here, right? So this is our import of our data. Cool. So one of these errors on import that you're going to see is if you go out and you do a topo and you hit a here key position, and this is a fairly common workflow, is people will go out, hit a here key, and then go shoot something, go locate some points, whatever that is, topo, as built, control, that kind of thing. And then they're going to process it later, right? You'll get this yellow flag that pops up sometimes. And that yellow flag, and here's a database showing that information. That's a warning flag. It's not necessarily an error flag, but it's a warning flag. And if we open up the flags pane, which is this up here at the top of the home ribbon on TBC, you can see where my mouse is bouncing in and out. There's the flags pane option. And if I close that, it disappears. If I open it, it opens back up. It tells you down here, this point is being used for all your data is less than survey quality. Right? So it's warning you, hey, this is not a control point by definition within the Trimble system, right? So we need to think about how we're bringing in data and how it's working. How was it brought into the access in the field? Was it a here key? Do I need to process it? It's just kind of a warning, right? So that's the low quality start point. So in best practices, if this is a site that we've been to over and over and over again, I would bring a control file in first. My first step would be to bring in a control file. That same JXL file that I used to create working files in the field, I would use that to create and set the parameters of my database, right? So what I'm going to do is I'm going to open up that database that we just created. Okay, so here's this one that we just imported, and I'm going to undo the import. So I have nothing in here. I'm back to, just the blank template with no information. We'll open that up and show that there's nothing in here. So it's back to defaults. So instead of bringing in the working file like we did last time first, what I'm going to do is I'm going to go and get my JXL control file. The reason I prefer the JXL control file over a CSV is the JXL control file carries over all of my projection information from that site. So in here now, instead of being defaults, you can see that it's now set up to be on the correct project information. If there's a site calibration, which this one has, there's that information, and we have that. Now, when we bring in the data, we can bring in our working file. So I'll go over here, grab that, and we'll go back to our working file. When I bring this same file in, it's going to have something to compare, right? We still get that same warning. I opened it up again. Yep, same warning. So that's the latest warning is always at the bottom. So that same point. But now if you look at this, these points, the yellow flag doesn't exist. And now point 100, which is where all the work was done from, or a lot of the work was done from, is control quality, right? So that's the best workflow to eliminate those warning flags and get that, and that way everything stays consistent. On a construction project that goes months and months and months, it can help you prevent what I refer to as control point drift, where you start getting all these multiple values of these base points, that are off a rounding error of 100th or less, and you keep going through. Well, if you lock them down as control quality, it will understand. Now, I've been referring to control quality, and we can spend this whole hour today talking about how TBC does what TBC does, and the decisions that are made behind the scenes within the software. There's already a really good power hour on this topic. If you go to the support ribbon in Trimble Business Center and you click on I'll bring up my laser pointer here. You click on this community forum button, then it'll open up a web page and it'll take you to the forums. You can go down to the bottom of that web page. At the bottom, you're going to see a video section, and then there is the Power Hour Vault. If you click on that Power Hour Vault, you can find all the past Power Hours and, you know, since they began, and you can click on these links. The one that you probably need to focus on is this March 2016 integrating RTK, total station level, and user information. And this one goes into great detail on quality, control quality, survey quality, unknown quality, all these different levels. And not only that, it goes into how TBC looks at RTK data different than total station data, and how TBC thinks behind the scenes. Very, very important. So I don't know if there's a more important webinar Power Hour to watch than this one. So this is the one I really push. I think it's worth everybody's time to take a look at it. Maybe watch it more than once, because there's a lot of information there that's important to you. Okay, so now let's talk about bringing in two files into the same TBC database. So we bring in this first file and it looks great, but now we're going to bring in a second file, and you get this other warning that says project coordinate system differences. So what I'm going to do here is I'm going to open up another TBC database, and we're going to look at, so here's our clean data from our working file 1. So we have working file 1 on a clean control file. And now I'm going to bring in a second day's observation file in here, and we're going to bring in the second working file. Okay, so the second working file comes in and it gives us this error on import, and it says project coordinate system, right? And then it says this does not, you know, they're different. Well, we need to find out what's different, right? Well, if we hit the details button, and you should always check this out if you get this warning, what is different? So here on the left side, I have the TBC. These are the values for the projection information for TBC. Here on the right side is the imported file projection from the daily. And if we roll down, we can look at what's the same and what's different. And what's different is highlighted. So it looks like the second working file that went out did not use the calibration settings that were created on the days prior, or created by the control file prior. Something went wrong. The data is still savable, but we need to now go through and make sure we update that. So let me minimize this. So in here, now I would select, and most of the time this is what you would select, but maybe not always. Most of the time you're going to select keep existing. If you're using the JXL control file method, your answer almost 100% of the time could be keep the existing project definition, right? I want to keep the TBC project because I use the JXL to set all my parameters. If I bring in another file and those parameters don't match, I want to keep the existing, right? So I hit OK, and then it's going to bring in, but you're going to notice when it brings this in, we're going to have problems, right? So it's like, hey, look at this. You've got this merge points on import, right? So the merge points on import screen is a very important tool that allows you to merge common points. And so when I open up this database, going back in there and grab the wrong one, so grab that one. Okay, when we look at this, because of the calibration differences, these values horizontally, they're huge. They are the same points though. If you look at the description, they were supposed to be the same points. So I don't really know what happened in the field because this is not my data. This is a customer who will remain nameless, was kind enough to share this data with us after I assisted them. But these definitely are the same. When I scroll down here, I can look, I'm scrolling down in the list. This one's definitely different. So I do not want to merge that one. That one should not be merged. These probably can be merged, right? So I can go through here. So you need to take some time and think about this. Does it make sense to merge them? Does it does it not, right? And then when you hit import, it will do that merge on import. Okay, so now it says you have 4 errors. All right, so if we go back into our PowerPoint here, hey, you now have 4 errors. What are these errors? Well, we're gonna point cannot be computed, grid values, that kind of stuff going on here. So we need to make notes of these points, and they're points we need to look at to understand what's going on. So we need to talk a little bit, and that power hour I sent you to from March 2016 goes into detail on this, but we need to take a look at when are we seeing an error flag. So if I go back into my database here and I say, do you want to view the summary? Yes, I want to view the summary. Here's our new points that are now affected by our problem, and we'll look at this. Now look at my data when I close that report. I have the original control file. This is where the information's good. Then I have 2 different sets of data from this next working file. One of them's up here, way up north. One of them's way down south. So something was definitely going on in this field file. There's some craziness. And so this is all down south. And so we need to get all this information back to where it belongs, which is in this center area here. Okay. Down here at the bottom in our flags pane that we talked about, you can see those huge errors we saw in import, right? So because we merged those points 100, we have 4 or 5 conflicts on point 100 that are off 5 million feet, right? Like, it's crazy. Up here at the top under the project settings, if I open up the project settings box, I can go into this computation engine, and that power hour that I sent you to will go into great detail on this. But in here, all of these settings, and I refer to this as your threshold to pain. Trimble has made some choices for you. Those choices may not be the choices you want. Just that you may want, your pain may be higher. You may be okay with a little more slop or a little more, error for this project, because this project might not be super critical as far as the horizontal or vertical goes. But then there could be other projects that you could be working in a downtown urban environment with 0 setbacks, with multi-million-dollar properties, or on a bridge, that kind of thing. And you might want to take these errors and like move them way down so that you're getting errors on any little thing, right? So there, you can control those flags in this section. So it's worth coming in here and looking. The other thing you can look at is the merge on import screen options. When we brought that in, you notice some of those points were checked as merge automatically and some weren't. I usually like to check them myself, and so I'll change this to custom tolerance, and then I'll leave these at 0s. So that way nothing ever automatically gets checked by TBC on import. I have to go through and check it and say, yes, that is the same point. Merge those, right? So this is a setting I like to change, but the default is ×3 of the point tolerance, right? And so when you look at your point tolerance here, it's going to be ×3 these values. That's the default. So if it falls within, under it's horizontally of a foot, that's where it's gonna let it. It's gonna say, yep, if it's less than that, we'll merge it. If not, we'll uncheck it. So those are options you need to look at. Okay. So there's lots of different options in there. There's options for GNSS vectors. There's options for total station, mean angles, all kinds of options. You can control the errors. Watch that webinar and get in there and figure out what's best for you. Okay, flag pane, we talked about that. Here's our errors. They're all over the place. We have problems. Okay, so we've looked at our data. We've evaluated our data. The next thing we can look at is how to actually start fixing things, right? How do we start fixing those problems that caused us problems? Well, we have to understand some basics. So here's what we're going to talk about in this section. This section, we're going to talk about the Project Explorer, the point derivation report, the total station editor, data spreadsheets, and merging and exploding points, because those are the tools we're going to use to try to get this data to work together correctly as it should have on import. Okay, so the Project Explorer. So where you get to the Project Explorer, here's the home ribbon. And if you don't have your Project Explorer open, you can open it here, but it's right here. And then it'll look like this on, usually on the left side is where I dock mine. I think that's by default, if I remember correctly, but I'll look at the information there. So let's open up a database here. And here's what the Project Explorer looks like with points. Here's what it looks like if we drill into a point using the little triangle symbol, we can drill in this information. So let's look at here. This information, if I drill in, I can drill into the individual files imported and I can look at what's going on, right? So here we have our 2 files. Up here, I have all of these points. Now see this point, if I click on this one, or even say 447, which is probably in this list somewhere, it's huge. These are all CSV, these gammon reels are all basically imported points into the job file. Well, I don't really need all these points, right? They're not really doing anything. These ones with the triangle have been deleted in the field, right? So something was going on. They knew something was wrong, probably, and that's why they deleted it. I don't want this symbol down here is a base station. So I'm going to take this and I'm going to delete those points, but I'm going to leave the base station. Then I'm going to grab this group and go up here and look for and here's that section, and I'm going to grab this and delete those. So now when I remove those, you can see how the information, if I recompute, I make a change, I recompute, I look for new errors, and then I can come down in here. So all of these values are values I can probably get rid of because they're stuff that was imported from a CSV file, which I probably have access to in the office that I don't need. But now notice all that information that was up here on the north is gone. So the information on the north end is gone just by drilling into this imported file section and removing that data. Now, the stuff to the south is not part of that group. And I'm looking at this second file we imported. This second file has as stake points. And so you have 2 different flags here. One's an out of tolerance, the big red one, and then the little orange flag is an as staked flag, right? So we need to look at that. As staked flags serve a purpose, okay? The idea behind the as staked flags is that if you're out in the field and you're doing some construction layout or you're leaving behind some lath for somebody else, when you stake it out and store that information, Business Center wants to lock that down because they don't want, if you start making changes to the database, you might want that to know where that data was, the cut or fill or the station offset, all that information. However, what happens a lot of times is people go out with some search coordinates for, say, a boundary survey, and they go out there and they start looking around and they load this CSV file that's search coordinates, and they go out and find the property corners, maybe even they calibrate to them and they search for them, but every time they stake it, they might store it in the field. They might store that point as an as staked. And when that happens, it locks these points down. And that's what we're seeing in this database. So this database down here has all these points that are locked down as staked. And if I don't care about them, we need to free them up. Right? We need to get them, let TBC put them back to where they should be based on the correct projection, not the coordinate system that was done in the field, right? Because I want to see where these are. So that's a decision you have to make. I can't always answer that decision for you, but how you do it is you collect whether or not I can't answer the decision if you want to do it. You have to make that analysis yourself. So you select the as staked points and then you right click on them and you can select this convert as staked point option. So what that looks like in here is in this database, which is not popping up for me here. There we go. We can click this point and I can go down to the bottom of the as staked list. I can hold down the shift key and I can select this one. Now, when I right click on one of these points, I get this convert as staked. Now watch what happens. I convert them. It does a recompute. And then I do a recompute, and then when down here below, notice that all these as stake points now have a -1. So the information from the field, if I want to keep it, if I want to look at what was stored in the field, I still have it, right? So I still have access to what was stored in the field, how far off they were, what they thought they were off. But I also now, if I go up here to the top, all those points with their, if I recompute here, there they are. All these points are up here. And now I have those same points, but now they're just a topo point, right? And I have the vector and the quality of the vector going to them based on the correct projection. So I can see really where they are on the site now, right? And I can go through. If I don't care about these points down south, these -1 as stake points, I can go down here and I can remove, I can do that same shift and I can delete these. And now when I recompute and zoom extents, so there's my zoom extents button. Now everything, all my as stake points are gone if I don't need to keep them. You still have them in the job file. If you need them later, you can go get them, but that's my preferred method. Okay, so that's how we convert as stake points, and then you can decide if you want to keep them or not. You know, keep the -1s for records inside TBC. So that's how you walk through it. We covered that, how they become back to normal topo points. We looked at looking at imported files and drilling down through there. You know, this example here, this is a base station, and this file needed this point to create this vector data from the GPS down below. However, we get it here first. That's why bringing in this JXL is important, because now we could remove this if this is a bad value. In this case, it's not, but this is where we could remove that in our imported file section. Okay. So that's as freeing up as stakes, looking at the flags pane, looking at Project Explorer, digging into the data. All the data is in there for all of our field observations. So if we explore in here and we go in here, see there's a problem there with this resection. The resection's on this point here. There's a problem. That's what these red flags are. So we're narrowing down where our problems are. We still have a problem on point 100. So I'm going to go up to the point section and I'm going to look at this and go, oh, look at that. If I go use a point derivation report, which is one of our next tools, I can look at this and go, look, everything agrees on point 100 except for this file, this value, the gammon reel, the CSV value that's coming from the second stake job. That's way off. Okay, well, that means I need to get rid of that. So that's this value here. So if you look at the northing and easting on that value that came in from that file, it doesn't match the northing and easting here, and that's the conflict. So I can click on this and I can either disable it by pulling that down, or I could just delete it because I know it's wrong. Delete it, recompute. Now we've solved the error on 100. So notice all our errors on 100 are gone. So we need to go through and do that. Not all of these errors are that easy to fix. Some of these errors are coming from prism constants or HIs and that kind of information. So in those, you have to look at the individual observations and find where those busts are. So here has this observation has a prism constant. If we look at all of these, I think I have some in here I found that do not have a prism constant, right? And so that's a problem. When we start looking at this data, we can go through there. See, here's one. It should have a prism constant, but it does not. And so something happened in the field. So we need to go and fix that, right? So there's lots of different ways to go and look at this, but you might not get an error flag if the point is not the same. So let's talk about points for a second. So what I'm trying to say by the point, if the point's not the same, if it doesn't have the same name. And so what happens all the time in the field, and this goes back many generations, we teach people, we teach staff, and this is a good example right here, point 102. So our control point's 102. Here's a check shot with RTK on point 102, but we called it 5002. Here's a bunch of check shots on 102 that are 1/10 away, more or less. This is 1/10 of a foot. You can tell by the graduation and the scales. But all these points over here are all point 102, just different measurements from different positions on the site for 2.102. But every time they shot it, they called it something else. TBC has no way of knowing that all these are points 102. So it won't give you an error if you store them as other numbers. So it's fine to do that, but you better write it down. And if you're trying to fix things and you want to know if it's right, what I would do is I would hold down the control key and I would take all of these points. So let's click these, and then I'll unclick the measurement vectors, click those, unselect the vector, even go into here, right? So now all I have is the point selected. I can go into merge points. So if I go up here to the survey ribbon and I select merge points here, I can then look at all these points, and so it automatically knows, TBC knows, because this value, our control point value, is control quality. These are survey quality, GIS quality, whatever, down on this one. So it's geoid quality elevation on the vertical on that shot. We can look at these and merge them. It's showing us what the error would be based on holding the control point fixed, right? And we can apply this. Now, on my slide, I wanted to show you something. I went in and I fixed prism constants. And so I looked at that same point, 102, and I looked at the errors, what it looked like before prism constants were fixed and after prism constants were fixed. And notice the difference. So I can merge these now and then go back in and change the prism constants and they'll all fit better, right? And that's what the point derivation report shows you. Like we looked at earlier with that, it'll say, hey, these measurements now work better because you added the correct prism constant. So there's lots of options there. So what we can do is going back in here, if I can find the correct database again. If we go in there, we can find that and we can merge those points, right? So very crazy. So that's what, that's the whole idea behind merging, right? So then we can look at the data in the Project Explorer. So the data in the Project Explorer, when we bring this up on the left, let me go grab this, and we look inside of it, there's all these symbols, all the symbology. We need to know, hey, what do these symbols mean, right? What's going on here? This is RTK data. Well, in here, everything in blue in TBC you can change, right? If it's grayed out, you can't change it here. So the best way I can show you that is if I go in, let me close my mouse pointer, or my laser pointer is messing with me. If I go into here and I look at this, if I look at, say, this value here, and I bring up the properties, I can change, there's a back bearing, right? And if I click up here, I can change the name of the point, right? Here, I can change the name of the point that's being backsighted, and I can change the information, but I can't change all the information in the same place. It might be listed in multiple places. You might have multiple data listed, but you can't change it. You have to find the correct spot in TBC to change it. So you have to sometimes drill down into these points. Like here you have mean angles, right? So we have this mean angle measurement 1, but I can't change the height, the heights for that. I need to go into here and change the prism constants there, right? So that's an important deal. Now the symbology. So when we look at here's a quick breakdown we made of the different symbology that you could find inside the Project Explorer and what those mean. So we have the data, the source data, the instrument, any notes made in the field, including deleting of points. That's a note. Single backside, you can undelete points that are deleted in the field. That's interesting. Most people don't know that. You can go back in and say, hey, why did they delete that? Undelete it. Oh, they did coded it wrong or something. Back bearings with a total station, your backsides. This is what the back bearings look like. This is the old version of the symbol and the new version of the symbol, depending on which TBC you're using. If you set up an azimuth, say you're starting a traverse from scratch out in the woods, and you just say, hey, I'm going to shoot this section line and call that east, and I'm going to traverse from here, and this is what that would look like. Here's your phase 1 observations, phase 2 observations, phase 1 and 2 backside observations, horizontal angle offsets, offset angles, angle offsets, mean angles, rounds, sets of angles. GNSS, base station information, vector level runs, point cloud. There's a lot of information here, right? But this symbology shows you of where you can go in there and look at it, and the more you do it, the better off, the more easier it'll get. Okay, let's talk about this point derivation report again. So as we merge points together, we get this point derivation report. You will get conflicts in that point derivation report, right? So when we look at this and we look at our data here, our points here, we can grab all these points again. I can unselect all the vectors, all right? So now I just have points and I merge them. So in here, I'm gonna go to survey and I'm gonna merge points. We're gonna look at that again real quick. Yep, that's what I wanna do. I'm gonna apply that merge. Now we'll hit recompute. I did that yesterday too, that's weird. Okay, so now this point 102 has a lot of values on it. So if we go into point 102, we have all these values now inside point 102. And if I do a point derivation report on point 102, it's going to show, and it highlights in red based on our threshold to pain from that computation engine, what points make sense, right? So I can look at the biggest errors first, solve the biggest errors, then I can go through here and look at these and go, oh, look, this is probably prism constants or something, right? The easting, because this is, most of these vectors are these total station vectors are coming in from the, from the east. They're more east, and then I have some, obviously I have some rod height bus in here that are 5 feet off, right? So it's either a measure up on the height of the total station, or it's a measure up on the rod, looking at these vertical errors, right? So I can use this point derivation report over and over again. So I'll make the change. I'll say, hey, that's the wrong value for point 102, delete. I'll do a recompute. And then I can click on this point again and do this, right? And now that value's gone. And now I can look at the next biggest value I want to attack, right? Anything in blue can be changed. So if I want to look at this information here and change it, I can scroll down through here and say, okay, here's my prism constant that I need to change to -30, that kind of information, right? So it's really, important to go through here methodically, carefully, slowly, right? If you merge points together that you decide later you should not merge, you can explode them. So the explode button, the explode points button is up there on the survey ribbon, just like the merge points. So up here, let me get back over there. There we go, there's my mouse. Here's the explode points option. And you can select the points you want to explode. It says, hey, there's 23 possible values that it could create for this. And then you could explode that. It'll put a -X behind them. So you can explode them and it'll make multiple, that like in this PowerPoint description, it'll make multiples, and then you can re-merge the ones that are appropriate. Maybe you accidentally merged something you didn't want to merge, right? So that's how the merge points and all that work. We looked at the point derivation report. That's really the tool I like to use for my blunder sniffing, to go through and try to steer me in the correct area. Now let's talk about the most common field errors. Wrong occupy point. This is the hardest one to identify, and that's a wrong backside point. Very difficult to identify, right? So that one's probably your worst nightmare. But you can get it if good notes were taken and you look carefully at the data. You can find it and fix it. The most common one is probably just measure ups. Measure up on the height of the instrument. Measure up on the method of the height, whether it's to the bottom of notch or to true height. Measure on the rod, right? All these measurement points you're taking in the field. So those are probably the most common measurement errors, whether it's a GPS base station, or you measure into the center of bumper or the bottom of the receiver. And then the last one that happens quite often is the prism constants. We need to probably do a better job as an industry explaining to young surveyors that are coming up in the ranks what a prism constant is and how it affects your horizontal measurements. Because I see that one very often. So I think we need to do a better job explaining why different prisms have a different prism constant based on the prism itself, and talk about what's the appropriate tool for the appropriate job, even when it comes into prisms. I like to compare prisms to hammers. If you were a framer and you're going up to frame a house, if you're working on the roof or versus working on setting up studs for a wall, you're going to use a different hammer, right? Prisms are the same way for surveyors. We use different prisms for different tasks, and so that's important. Okay. The next thing I want to talk about, and this is a and more option, is if the Project Explorer option that I prefer, that I've learned how to use and been using it for many years since TBC came out. I've been using TBC since version 1. The Project Explorer option isn't sometimes is difficult for people to wrap their head around of what's happening. So you have another option with total station data that you can open up the total station editor tool. And the total station editor, as you can see here in this screenshot, the total station editor allows you to change the data in blue and make changes to the database, but it lays it out more like a field book. So it's a little more user-friendly, and you can't change everything in here, but you can change a lot of things in here. So this is helpful, right? You can see here's my prism constants that are missing, and here's what they should be. So I have to go through and change those and make those correct, right? And this was in those rounds. So it's just like anything in TBC. If it's blue, you can change it. If it's grayed out, you can't change it here, but you possibly can change it somewhere else. Okay, so data spreadsheets. So the last and, the more and we get here, the better off we are, is I prefer sometimes to look at the data through a data spreadsheet. So up at the top of TBC on the home ribbon, you can go to this section here called data. And this data section, there's all these data spreadsheets, and this is the optical spreadsheet. So if I show you what the optical spreadsheet looks like, here's all the optical measurements for the job that we've already imported into TBC. So I can change anything in blue, like we said earlier, and stuff in gray I cannot change here. Well, guess what? There's other stuff, there's other items in here, and you can open up your TBC database and you can go up to the project settings, and then in the project settings, you can go to the view section, and then you can scroll down and look for the optical spreadsheet. Now here you can see in the optical spreadsheet what's being shown in the data set when you click optical and what's being hidden. So you can come in here and say, hey, look, I want to hide some of these things that it's showing, but I want to show things that are hidden, right? So usually there's a few in here that I like to turn on, right? You definitely want to show your backsides and foresights and that kind of stuff. So you need to look at that. And then when you click on your optical spreadsheet, this automatically updates. So if you want to hide some of these things, you can hide them. You notice this list is a lot more extensive than my screenshot because I've gone through and turned some stuff on. You also might want to turn some stuff off, right? If it might not make sense to have it. You can pick these up, these fields or these columns, and move them around also. So you can move this over here if you want to. If it makes more sense for you to look at it that way, you can make that change on the fly as you're going through it. So very important information to go through this and narrow it down and track it down. So I've narrowed down in this, I've fixed most of the errors in this data set by going through all these very methodically. And so here's what we just talked about. Here's the things I normally add is prism constant, station method, target method, and backsite. Make sure those are added if you're looking at optical data. I think it's very helpful. The last thing I want to say, or one of the last things I want to say, is don't make it worse, right? So you need to take your time if you're trying to repair this and go slow and don't be rushed. because if you see this error pop up in your flags pane, point could not be computed. That means you've done something and the data could be broken. So my recommendation is you go through and make these changes, change a few things, do a recompute, look at your flags warning and watch out for this, right? Watch out for this point could not be computed. If that pops up, you might need to undo what you just did, remove that change because you could be causing more problems than what you're trying to fix, okay? So basically you remove data that is critical to TBC calculating the points, and you can do that for a whole bunch of things, right? So just be careful. Another pitfall you could fall into is if you go out to send somebody out, or you go out yourself to a project and you do a site calibration, and then in that same job you set up and do a bunch of total station observations on the first day out there. Then you take that information and bring it in TBC and decide in the office that you want to change the site calibration, which happens all the time. There, you might need to go in and disable the optical measurements disable those optical measurements, redo your site calibration, and then re-enable the optical measurements after the site calibration. So sometimes TBC will kick you an error that says, hey, you can't change this calibration because you got these points are locked down. So this is something to be aware of. The pitfall there is this note right here is, had any of the observations been disabled in the field. So before you disable them, you need to look at which observations were shut off in the field, because you might not want to turn those back on. So you need to pay attention to the chronologically when you do this. That can make life a little more difficult. So pay attention to that. And then recompute your project and make sure it works and that you've got all your points so you're not seeing that crazy error. Things you can't fix. So this is kind of wrapping it up here, getting close to our time. We can't fix bad initialization. So it's extremely important that your field crews or yourself, when you're out in the field using RTK, that you take the time to make sure. So 50 feet of movement with the initialization plus 15 minutes with that initialization. That's my general rule. I picked up years ago. That's what you want to use to make sure your initialization is good. It's good practice. If you haven't had your initialization and moved 50 feet, or you haven't had it for 15 minutes, it may be questionable. You got to be careful. The receivers are getting better and better, but it's up to the person in the field to know that that's good. You can't fix that in the office. Taking shots with GPS where you shouldn't, right? Good survey practices. I can't fix bad data. Like if you have bad RTK data, can't fix that. So don't do it. Use the appropriate tool for the appropriate job. There are tools that require total stations. There's tools, there's scanners. Use the appropriate tool, right? We have lots of tools at our disposal, but not one tool is not perfect for everything. So we have to use that. And then if you're missing the field notes, I told you how many phone calls I get about this topic. I get them every week. Unfortunately, most of the time, or at least half of the time, they don't have field notes. The data we're working with today did not have field notes. So I can only take it so far with confidence. The whole idea is to what you guys walk away with this with confidence and know, hey, this is what we're doing and I can repair the data. But if you don't have the field notes to cross-check, because people are like, oh no, all the notes are in the data collector. Well, no, we're fixing what was in the data collector. That's what's broken. You did something wrong in the field and now we need to fix it. Well, if we don't know what to fix, we can't do it. So that's it. So that kind of concludes us. It looks like we're doing pretty good for time. Shane, I think you wanted to jump in here and say some things.
Yeah, let me go ahead and get it back over to me real quick. I
Sure.
want to give a big thanks to Dustin for putting this together. We've had some really good feedback, not only in the questions, but I've had some people chatting on to me as well. So great presentation, great delivery, Dustin. Thank you.
Thank you.
So I'm going to get the screen back over real quick before we end. I just want to show you guys some of the new features that we have available, and some of the resources we have available. There's a couple places you can go for this. This is a screenshot of our homepage, and then everything can be accessed as well through the ribbon inside a Trimble Business Center in the support tab. But I just real quick want to run over to, this is our homepage. So if you come to the homepage, you scroll down, you're going to get some product information and support and downloads. One of the best resources I think we have out there that we update on a monthly basis is this resources PDF presentation. We are constantly adding new learning material, new videos, YouTube videos. Every Power Hour that we do gets added to this, and it is updated on a monthly basis, like I said. So if you click this, you have to download the PDF, and then from within there, this will open up to this. What's really nice about this is the way that it is all split out by platform and topic. So if you go down here, you're going to see all the different platforms as you go down. That you'll see the homepage, tutorials, YouTube channel, Power Hours, and then one of the best things I think we have is it's split out by topic. So if you go to here, you see all these workflows and all these topics. If you select one, this will take you to links to everything we have available on that topic. So GNSS data, RTK, and baseline processing. This is the Power Hour here that Dustin had mentioned at the beginning, and I 100% agree with. This is probably one of the best Power Hours we have as far as information combining data. So I encourage everybody to get on there and look at that. And then download this document. Anything you guys are looking for, this learning material is out there for some self-paced learning. Go back to, so join us next month as we kind of piggyback off what Dustin's doing here, and we're going to take a deeper dive into some optical workflows and traverse adjustments. I think this is a much needed one as well. We've had a lot of requests coming in for it. We'll look at the data coming in, some different ways to look at that data, fix some errors that come in from the field, and then turning that around into a final traverse adjustment and final coordinates. And with that, we're right about the time. We did have some questions come in that we'll be getting back with you guys, either Dustin or myself, but it usually takes about a day. We get a list of all the users with their emails and all the questions that came in. So we'll definitely be reaching out in the next week to everybody, getting any questions you have answered. If there was any problem with data or anything, we may request some data from you guys. But yeah, thank you very much for your involvement. And Dustin, thanks again for the Power Hour.
Thanks for having me, Shane. I enjoyed doing it.
Everybody have a good rest of your week.